Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 2 for this week. And I'm going to confess up front that producing the graphics to try to explain what I'm trying to explain was not the easiest thing. And I've never professed to be the greatest artist in the world, let alone the greatest graphic artist in the world. But I hope that I can at least have enough of a basic graphic presentation to drive home the point that I'm trying to make. But the topic for today is what is the ideal upper level flow pattern for snow events, significant snow events in central and eastern North Carolina. And it may surprise you that it's not quite as simple as a lot of people think. So let's go on ahead and get into this here. And first, what we're going to have to do is do a little bit of review on something called jet streaks, okay? Now, jet streaks are simply areas within the jet stream where the wind is blowing stronger than it is anywhere else. And because of the imbalances that occur when winds are moving along in the flow and they encounter these jet streaks and accelerate into them and then decelerate coming out of them, it sets up various convergence and divergent wind patterns. So basically, we split these jet streaks up into 4 quadrants, and we have upper level divergence, and there's actually a bonus weather video a long time ago that actually talks about the science behind all of this. But basically in the left exit region, so the wind is blowing along like this. So it's coming out of the jet streak here. So this is the left exit. This is the right entrance region. Those 2 quadrants have upper level divergence. And then the left entrance region and the right exit region have upper level convergence. Now, what does that then result in the low levels of the atmosphere? Well, it's exactly the opposite. We have low level convergence in the left exit and the right entrance, and we have low level divergence in the left entrance and the right exit. So when a jet streak is coming along, a lot of times you will see storms develop up in this quadrant here, okay? And down in this quadrant, you can still get storms to develop, but sometimes it isn't so much that the pressures are all that low, it just sets up a very broad upward motion pattern, which can result in widespread steady precipitation. So because of these various patterns that set up, we have rising motion in the left exit region and the right entrance region, okay? So remember up in here, we have upper level divergence and low level convergence. So the air is coming together in the low levels, it's going up, and then it's diverging at the top. And the same thing is going on here. And then in the left entrance and the right exit, you have sinking motion, where the air is converging at the top, sinking, and then spreading out when it gets near the ground. Okay. So this is what we call in the upper atmosphere a full latitude trough. And basically what we mean by that is that the trough axis, which is sitting right in here, extends all the way from high latitudes down to low latitudes, okay? Now, we've talked a lot about the fact that to the east of the trough axis, you get rising motion, okay? Well, in this kind of a situation, you're going to get broad pressure falls all up and down the trough just to the east of the axis, okay? And so if the pressure is falling just as much up here as it is down here, and we've got low pressure back here, then you have a broad southerly flow, and it warms up and it rains. How many times have we seen that, okay? And then once the trough moves eastward, it gets colder, but it's dry, okay? And so full latitude troughs rarely do the trick for central and eastern North Carolina. The only time that it can is, we've talked about this concept of vorticity, where we have a maximum of vorticity right along the trough axis here. If the jet stream is so far south that the maximum vorticity area actually passes to our south, like let's say it's down in here along the Gulf Coast and it rotates up the eastern seaboard like that, then you can pull it off, okay? But rarely is the vorticity maximum that far south. And so usually it's just, you know, it warms up and rains ahead of a cold front comes through, and then it gets cold, but it's also dry. And then the next system comes along and it warms up and rains, and then it gets cold and dry again. So a very frustrating pattern. So what is the ideal situation for a major winter event in central and eastern North Carolina? And this is where my graphics get a little shaky, so I'll try to talk both of us through this, okay? So here we have the United States and Canada and Mexico. So we're going to have a split flow here where we're going to have a defined jet stream across Canada into the northeastern U.S. and another branch of the jet stream along the southern tier of the United States, okay? Now, you notice how I tried to draw the lines here so that they're getting closer together, that they're more tightly packed here than they are up in here, okay? So we've got a jet streak located in this position here, and a lot of times you'll actually see like an upper level low sitting here over the eastern Canada provinces and the counterclockwise flow around that, and there'll be a jet streak in this location. Then we have the southern branch of the jet stream, and I tried again to show that the lines are more tightly packed in here than they are here or behind it. So this is another jet streak here. So now let's put our quadrants in there, okay, for both of these jet streaks. Now, remember that there is going to be rising motion here and also rising motion here and sinking motion here and sinking motion here. So in this area here, if the air is sinking here and rising here, that means in between those two, the flow has to be coming from the northeast toward the southwest, okay? So you have air sinking and you have air rising over here, and let me do this like this, and so something has to connect the two, okay? There's air leaving here, and so something has to come in to replace it, and so it does, and what that does is set up a low-level flow out of the northeast, which drives colder air from eastern Canada down the eastern seaboard, especially east of the Appalachians, and that is the cold air source, okay? Then, in the southern branch of the jet stream, remember that we have rising motion here and sinking motion here. So if the air is sinking here and rising here, again, something has to come across in the low levels to replace that air that is rising. And so in that case, you get a flow out of the southeast, which is helping to transport warm, moist air from the Gulf of Mexico and the Atlantic Ocean, and then that warm, moist air is forced to ride up and over the cold air that is being supplied by this jet streak up in here, okay? So these two have to be, what's the word, juxtaposed, I think that's the right way to say it, just perfectly, so that these two jet streaks are in exactly the right locations so they can work together to drive the cold air in the low levels and then bring the warm, moist air up from the south. And there are two gentlemen that wrote a couple of volumes about great northeastern snowstorms. And one is Louis Uccellini, who is very famous in our field. He was actually the director of the National Weather Service for several years. He's now retired. And then Paul Cosin, who I actually went to school with. He was a graduate student at Penn State when I was doing my undergrad there. And the two of them actually met, I believe, at NASA Goddard, and then decided that, hey, you know, let's do a study on these snowstorms. And they found that this was one of the common elements to all of the great snowstorms that occurred in the Northeast, is having a split flow and having the two jet streaks in just the right locations so they could work together to supply the cold air and supply the moisture, and as a result, get a significant winter precipitation event. So I hope that makes a little bit of sense. And obviously, it's a tough thing to come about because it doesn't happen all that often in the Southeast. Sometimes it'll come together much more often in the Northeast, in the Middle Atlantic states, than it does here. But this is really what you want to look for. And El Niños are famous for split flows, okay? The only problem is you still need that cold air supply with the northern branch of the jet. And if that northern branch of the jet is not in the right configuration, then instead of it being cold and wet, it just ends up being mild and wet, okay? So that's obviously not what snow lovers want. So, All right, so that is the ideal pattern for major winter events, and for you snow lovers out there like myself, hopefully we can get one of these this winter. That'd be fun. All right, that's it for now. I hope you have a wonderful Wednesday evening, and we will talk to you again with the next bonus weather video Friday, the next daily weather update coming up tomorrow. Take care, everybody.